So my molecule was C10H12O. So I started off by calculating the degrees of unsaturation, which the formula is 1/2 times 2n, which is the number of carbons, plus 2 minus the number of hydrogens. So when I put everything into the formula, there's 10 carbons and 12 hydrogens. I ended up with a degree of unsaturation of 5, meaning there is at least 5 double bonds or ring in the structure of C10H12O. After that, I moved on to analyzing the IR spectra. I started off here by finding the CH stretch point, which is around 2950 centimeters to the -1. Around here, around 1715 or 1700 centimeters to the -1, I predicted to be the C double bond O stretch. And then this area here, I predicted was a benzene ring. So then putting that into our table here, we have a frequency of 2950 centimeters to the -1. And I identified that functional group as a CH stretch. The following was around 1715 centimeters to the -1. I identified as the CO double bond stretch, specifically a ketone for 1715 centimeters to the -1. And finally, around the area of 1600 centimeters to the -1, there was a few peaks, and I predicted that to be a C double bond stretch for the benzene ring. And this would make sense for our degree of unsaturation being 5, as there would be a C double bond O stretch and a benzene ring with 3 double bonds and the ring structure giving us a degree of unsaturation of 5. Then I analyzed the 13C spectra here, and I got a C double bond O stretch just over 200 ppm, and then here is where I predicted the benzene ring to be between 120 and 140 ppm, and then this area here would be the sp3 area below 100 for the CH2 and CH3 groups in the molecule. And now we just put this into our chart. So at 9 ppm, the type of bonding environment would be sp3. There was a few other peaks in the sp3 region, 35 parts per million and 50 parts per million. All of those would be sp3 since they're below 100 parts per million. The final four, 128, 129, 130, and 210 parts per million, are within the sp2 region, with the 128, 129, and 130 parts per million being a part of the benzene ring, and the 210 parts per million being a part of the carbon double bond. And here's me just describing that those 3 sp2 bonding environments belong to the benzene ring, and the final belonging to the ketone. Finally, I analyzed the 1H NMR spectra. Here, with the integration of 5, I predicted this to be the aromatic hydrogen region, as it's a little bit higher than 7 parts per million. Here, with an integration of 2 hydrogens, around just over 3.5 parts per million, I found a singlet and predicted that to be a CH2 group just beside the benzene ring, which I labeled here as the benzylic methylene group. This next peak here is an integration of 2 hydrogens, and it is a quartet, and it was a CH2 group that I predicted it to be. And then here it's a triplet with an integration of 3 hydrogens, and I predicted that to be a CH3 group since there's 3 hydrogens. So putting that into the table here, We have a chemical shift around 1.0. That's an integration of 3 hydrogens. That's our CH3 group. The multiplicity was a triplet. And this here is a little bit of a partial structure that I drew just for reference, showing that it's the terminal CH3 group. And then at a chemical shift of around 2.5 parts per million, I found there to be an integration of 2 hydrogens, and this appeared as a quartet on the 1H NMR spectra. And here's me drawing a partial structure just showing that it's the CH2 group in between the ketone carbonyl and the terminal CH3 group. And then the next peak was 3.7 parts per million, which was also an integration of 2 hydrogens, and this appeared as a singlet. And this is me just drawing to show you that it's the CH2 group just adjacent to the carbonyl carbon right next to the benzene ring. And then at 7.25 parts per million, there is an integration of 5 hydrogens, and they all appear as singlet. And this here is just me demonstrating that it is an aromatic hydrogen. So just to make drawing the structure a little bit easier, I just want to go back to the 1H NMR spectra and highlight the integration values here, just so that I can show you with color coding on the structure which atom each of these peaks is corresponding to. This makes it easier for me to analyze the structure. So I predicted the structure to have a benzene ring. So 3 double bonds and a ring is 4 degrees of unsaturation. And then there's a butane. And then we made it a butanone, ketone. Adding in the hydrogens here, which I will highlight very shortly. And the ketone carbonyl just demonstrates that 5th degree of unsaturation, coming to a total degree of unsaturation of 5, which we calculated in the formula at the beginning. So labeling these hydrogens here just for reference, looking back at our NMR, 1H NMR spectra, this is the color coding. And I will color code them in this chart just for simplicity's sake as well. So the terminal hydrogens are in blue. That's on the terminal CH3 group, which I will highlight in the chart here. The CH2 group attached to that will be highlighted here. And then the benzylic methylene group I'll highlight in purple, and the aromatic hydrogens